In this video, we will examine some do's and don'ts when working with exponents, namely when multiplying versus adding and subtracting. First, let's remember the basics about exponents. What is an exponent? Well, if we have a number being raised to a power, the number represented by b here is what we call the base of the exponent. And the superscript, the small number that's kind of floating in the air, that is what we call our exponent. Well, what do exponents mean? Based on our understanding of exponents, we should know that x squared means that we're going to multiply that base of x times itself, the number of times indicated in the exponent. So x squared means x times x. X to the third would mean x times x times x. X times itself 3 times. 3 to the fourth power means we're going to multiply 3 by itself 4 times. So 3 times 3 times 3 times 3. We could do some multiplying here and figure out what that is. Think 3 times 3 is 9. 3 times 3 is 9, so 9 times 9 would be 81. 3 to the fourth power is 81. Negative 2 being raised to the third power. Well, let's look. What is the base of that exponent 3? The base is negative 2. So negative 2 is being raised to the third power. So that means we're going to take negative 2 times negative 2 times negative 2. Again, let's go ahead and simplify and see what that is equal to. 3 negatives, negative times negative, is going to yield a negative because I have an odd number of negatives. And 2 times 2 is 4. 4 times 2, negative 2 cubed is negative 8. Okay, now let's look at multiplying terms with exponents versus adding terms with exponents. Based on our properties of exponents that you learned in previous videos and lessons, multiplying like bases means that we're going to keep the base and add the exponents. So don't forget those rules. Let's look at the first example. X squared times x squared. We're going to keep the base of x and add the exponent. So 2 times 2 is 4. X squared times x squared is x to the fourth. Let's look at the parallel example with adding like terms. What if I had those same terms, x squared and x squared, but instead of multiplying, we were adding? We should not get the same value because the rules are different. When we're adding and subtracting like terms, we want to think of these like terms as objects. Maybe you have x squared, think of it as maybe a square. If I've got 1 square plus 1 square together, I've got 2 squares. And what was our square? X squared. Hoping that wasn't too confusing with all of the squares. But what we see when we're adding is we're adding the coefficients here, not the exponents. So when you're, remember our notes from earlier, when you're adding and subtracting with exponents, do not mess with the exponent. Simply combine the like terms. So x squared plus x squared equals 2x squared. Let's look at the next parallel examples and compare. For example 2, I have one monomial, 3x squared, being multiplied by another monomial, 2x cubed. Well, when we're multiplying, 3 times 2, we get 6. And when I multiply these like bases, remember the rule, keep the base, add the exponents. So 2 plus 3 is 5. So when we're multiplying 3x squared and 2x cubed, we get 6x to the fifth. Let's look at the parallel example on the other side. We have the same monomials, 3x squared and 2x cubed, but now we're adding them together. When I add 3x squared plus 2x cubed, I want to think about like terms. And based on what we understand, we should see that x squared and x cubed are not the same. So you cannot combine here. This is as simple as it gets. So this is already simplified. You cannot combine or do anything with this example. Okay, let's go ahead and look at our next parallel examples. So we have a binomial x plus 3 in parentheses being multiplied by x minus 5. Remember, when there's no symbol in between, that means multiplication is happening. A few of us have forgotten that. We must remember what operation is happening between these two things. They're being multiplied. So when we're multiplying a binomial times a binomial, we have to remember that we need to distribute everything in the first binomial to everything in the second binomial. So essentially, we're going to be distributing and multiplying 4 times. Let's take a look at what that looks like and remember. So x is going to be distributed and multiplied, as well as the positive 3. We're going to distribute and multiply there. So x times x is x squared. When you're multiplying like bases, you add the exponents. There's understood ones there. X times negative 5 is negative 5x. 3 times x is 3x. And 3 times negative 5 is negative 15. So when we multiply x plus 3 times x minus 5, we get x squared minus 2x minus 15. I've combined my like terms here in the middle. Now let's look at the parallel example. On the other side, example 3 over here, in this case, we are not multiplying. There's a big plus sign in the middle. So look visually and see the difference. Not the same. Different, different. So when I'm adding, I simply need to combine my like terms. I have an x and an x here, so that gives me 2x, and 3 minus 5 gives me negative 2. So two different answers because these are two different problems. One where we're multiplying, one where we're adding. Don't go multiplication and distributing crazy. Know when you can distribute and when you cannot. All right. Now, I want you to try. Relook at some of those examples. Pause the video at this time and restart when you're ready to check your answers. Remember, you got to practice by yourself. Don't be afraid to make mistakes. You might mess up, but try them anyway. The best way to learn is by doing. So pause your video at this time. Try these 4. Come back when you're ready to see how you did. For number 1, x cubed times x squared. When we're multiplying, we keep the base and add the exponents. So you should have gotten x to the 5th for number 1. For number 2, I realized that this is an adding problem, so I want to look for the like terms. There is only one x cubed, so I'm going to bring down my 7x cubed. There's only one x squared, so I'm going to bring down my positive 2x squared. But I do have some like terms here with x. Negative 2x plus 5x is 3x. And my number of a negative 6 is all alone. We'll just bring him down. So we've combined like terms, and you should have gotten 7x cubed plus 2x squared plus 3x minus 6 for number 2. For number 3, hopefully you noticed there was no symbol in between here, so that means you should have multiplied. If you've done your distributing correctly, you would have gotten x squared plus x minus 4x minus 4. And then when you combined your like terms, you should have gotten x squared minus 3x minus 4. For number 4, again, I noticed quantities being multiplied. So let's multiply the numbers. We get negative 18. When you're multiplying like bases, keep the base, add the exponents. There's an understood 1 there. So for number 4, you should have gotten negative 18x to the 4th. How'd you do? Hopefully you did well. If you missed some, write down your specific questions and bring those to class ready to ask. Now, the last thing I want us to look at are some do's and don'ts right next to each other to highlight the things that I'm noticing some of us are making mistakes with. Now, let's look at what to do versus what not to do. When we're adding, you're going to be adding the coefficients. Do not mess with the exponents. So 1x plus 1x is 2x. Do not try to make changes to the exponents here. Do not take x plus x and write x squared. That's a no-no. Do not do that. Don't try to add the coefficients and get 2 and still add the exponents. Neither of those is correct. When you're adding, do not mess with the exponents. Let's look at the next one. Here, again, this is an adding problem, so I'm only going to use the exponents and variable to identify the like terms. I've got 2x squareds plus 2x squareds. Your answer would be 4x squareds. Again, do not try to mess with the exponents. You should not be saying that 2x squared plus 2x squared is 2x to the fourth. It's not that. You also should not be still adding the coefficients and trying to add the exponents. Again, when you're adding with polynomials or with exponents, do not mess with the exponent. Just think combining like terms. Okay, let's look at another. X times x when we're multiplying. Multiplying is when you mess with the exponents. Multiplying and dividing, you can make changes to your exponents. So x times x, the rule says keep the base and add the exponent. So that would be x squared. Do not confuse your multiplying with adding. Do not say that x times x is 2x. That is incorrect. Know the difference between adding and multiplying. All right, let's take a look at a quantity, 2x plus 6, or x plus 2 plus x minus 6. Here, this is an adding problem. So you are not going to start distributing. When you see parentheses, you may think distribution, but be careful. The distributive property is a type of multiplication, not a type of adding. So make sure that you combine your like terms, x with x, that would be 2x, and 2 minus 6 would be negative 4. This is the correct answer. Do not overlook the plus sign here and start distributing because you see parentheses. Parentheses don't mean to distribute. Multiplication is distributing. So we've got to see that difference. So you should not be getting x squared minus 4x minus 12. Do not try to distribute. And lastly, one other thing that I wanted to point out to you, our understanding of exponents. If we know what raising to the second power or squaring means, we should see x minus 3 quantity squared and know that that means x minus 3 is being multiplied by x minus 3. So in this type of problem, where you have a base of x minus 3 or a base that's a binomial being squared or raised to a power, expand that problem first so that you can see what has to be distributed and multiplied. So we should end up with x squared minus 3x and minus 3x and plus 9. So we get for this one x squared minus 6x plus 9. Do not try to distribute this square over your subtraction, or even if it were addition here. That's a don't. You cannot say that x minus 3 is x squared minus or plus 9. You can't just square those. You must expand and distribute so that you can get that middle term on your trinomial. Okay, I hope that is a help for you. Definitely take a look back at these, practice, review, retake notes, and be ready for your assessment on exponents.